So I'm going to take on a little bit of this homework assignment, the parts that I think we didn't really address at all, but it's been fun to see people how they've kind of gathered old news and old skills from the past and were able to work it out. But I wanted to give you some background. So this is called composite functions, and it's that last page of that sheet. And when I say composite functions, they are you're composing functions from other functions, and you put one inside the other. There are issues that it actually generates the domain, and it says state the domain of each of these because there's kind of some cool things that happen. First, if we interpret this FOG notation may not be familiar to you. This means f of g of x, and this means, remember, g of x needs to go inside of f of x where the x's are. So ultimately, what you're going to get is you have this 3 and this something squared. That's your f of x function, right? That's the piece on the outside. And then what happens is you're going to take that g of x function, whatever it is, and so if I circle it in green, it's going to go right here inside of there, and you're going to compose a new function. So f of x is on the outside in blue, and then you get g of x on the inside, and I'll let you finish the rest. Now let's talk domain a little bit. When you compose functions, put one inside the other, it really does. There's a rule that when I teach composite functions completely, then you say the inside function has a domain, and the inside function's domain, when you put it inside another, the composite function that you create, no matter what mathematics happens, will have the same domain as the inside function, and it will include the domain of the inside function. So case in point, so square root of x plus 1. Now let's talk about this. This is a radical moved left 1. So I have a graph of it going right here on demo. If you go left 1, that graph has a domain that goes from -1 to infinity. And the thing is I'm going to put it inside g of x, and we all know it's going to cancel and produce this equation 3 times x plus 1, which is 3x plus 3. Right, so that's the equation we get because you square the square root on that top section here. If you can see my cursor, the radical cancels and you get x plus 1, and then you take it times 3. 3x plus 3 is this nice purple line. Okay, all is well. Now the thing is though, if you actually compose them, like put one inside the other, this is what you really get. This is the graph of the composite. Like this is g of x, square root of x plus 1, inside f of x, 3 blank squared. And the line you get isn't the full, line 3x plus 3. It's actually only part of it. It only starts at -1. It has the domain of the inside function, that's square root of x plus 1. So a composite function always inherits the domain of the function on the inside as well as what it results in this case a line. So you have to, and domain is just what x's exist, whereas the graphs start on the left and end on the right. So this one has a domain of -1 to infinity, and it's because the inside function had a domain from -1 to infinity, even though our composite function very much looked like a line, 3x plus 3. It came from somewhere. The original pieces that composed it had limited domains, and we have to honor that in the final graph. By the way, if you use Demo to make your composite function, it will put the appropriate domain. So this is correct, and it's the correct graph of it. So that's one way to make that happen as well. I'm just going to log back in here on my iPad. Okay, there you go. And another thing about that composite functions, g of f of x, again, is just putting f inside of g, like this. And the last one here, this means f of x divided by g of x. It doesn't mean like f divided by g and then times x or something like that. There's a bit of confusion there. These are old notations. Just show me f of x divided by g of x. Something to keep in mind, when you do put g of x in the denominator, there's some restrictions on there. You can't be 0. So just think of things that domain is really a statement of what x can be. And it's also looking at the graph. It's where the graph lives from starting on the left going toward the right. I'm not looking for perfection, but I'm noticing that a lot of you are getting these right, and I'm curious about how that happened and where, happily, I think many of you remember this. The others are finding ways to figure it out. Those are a few hints, and of course, I've helped others personally, so you can come see me as well. The decomposition one is meant, it can be many varieties of things, but I'll give you an alternative example if I call this like another h of x down here. And if I had, 2x over the square root of x plus 3, okay, this would be if I decompose this into some f and some g, by the way, it says you're doing f of g of x. Okay, so I'm trying to find some, so f of g of x equals h of x, same thing as what I'm seeing up above. But what I'll say is what would be my f that would make this happen. I could call my f of x, let's see, what would work? 2x over, well, actually I think I need to change this up a little bit. When you write it on the fly, I meant to just put 2 in there. Beautiful. If I do 2 over x is my f, then my g of x function, the one I put inside it, could be, one of many options, is square root of x plus 3. Because what would happen is I would put that function right here inside where that x is. You replace x within f of x with the square root of x plus 3, and voila, you get the function at hand. Now that's not the only option, so it's just one of many ways we could go about it. I could also take on this option 2, so here's, we'll call that option 1, and then option 2, if you're interested, is if I say f of x, let's call it that, is 2 over the square root of x. So a little more specific. Something like that. And then g, in order to get the result 2 over square root of x plus 3, would have to just be plain old x plus 3. Because when I put that inside for x, right there, in the f of x function, then it would result in my overall function of 2 over the square root of x plus 3. Okay? So that's decomposes. Come up with two functions, and when you put them together, you get h of x. So I'll let you go and have some fun with your number 10. There's a lot of variety and possibility that goes with that. Hope that helps you out. I'm going to hit pause or stop on this one and send more help as